Good morning and good evening, everyone. My name is Prashant Kochawara. I'm the Director of Product at Trilio, and today I'm here to provide a briefing on the top 10 requirements for cloud native data protection. This is going to be a guide for selecting the right data protection for Kubernetes. A little bit of background about myself. I am the Director of Product at Trilio. I'm spearheading the cloud native or the Kubernetes venture of creating a data protection solution out here. In my previous life, I've done software development, I've done systems engineering, worked with a ton of different products, created a lot of different data protection products and services as well. And today I'm here to impart some knowledge around the space that we have captured and gathered so far. So the agenda for today is as follows. Before diving into the requirements, I'm going to talk about the customer problem. And the customer problem, we are going to take a look at it from two angles. One is from a business perspective, and then the second one is from a technology perspective. After we kind of hash that out, we will jump into the requirements in a sequential fashion. And to make it easy to understand, I will frame this as part of a user journey, talking about the deployment, the backup, the restore, talking about other logistics around data protection, so that it makes more sense as to what a user would be doing when using this technology. And then finally, we will get into a summary where we will recap the kind of use cases that we want from a data protection solution, and obviously going over the top 10 requirements, making sure that we are taking the right learnings home with us. Now, without much ado, let's jump into the customer problem. As mentioned, we are going to break this down into a business perspective and a technology perspective. First, let's talk about it from a business angle. Now, it is no new news that data has been growing at an exponential rate. Based on recent studies done by Forbes, we see that every human is going to be generating almost about 1.75 megabytes every second. To put that more into perspective, the amount of data that existed before is going to grow 44 times to up to 35 zettabytes. Now, that is humongous. That is a huge number. And data has a direct impact on organizational growth. Why? Because data is directly used for analytics. It is the key engine or the most important aspect of what machine learning and artificial intelligence depends on. So if an organization has to be looking into the future as to how they shape up their venture and how they maneuver through this modernization journey, data becomes very, very important. And because it is important, it needs to be protected, it needs to be stored, and it needs to be secured. On the other side, let's look at the growing market of Kubernetes. If you look at analyst reports, you will see that every analyst report is on average saying that the Kubernetes market is growing at about 30% compounded annual growth rate, and it's going to be about 9 to 10 billion in 2020. Why is this market erupting or taking off so swiftly? One of the biggest things is that Kubernetes is enabling faster software development and delivery. As a result, newer applications or newer technologies, services, everything are being developed in a cloud native fashion or a cloud native order. And the older applications are being re architected to fit into the Kubernetes constructs as well. And what we see is that leading vendors like Amazon, Google, and so on, everyone is kind of converging into the Kubernetes space. A good testimony to this is the recent announcement of Amazon controllers for Kubernetes. We see KubeVirt, which is converging VMs and containers together on a Kubernetes plane. Similarly, we have VMware Tanzu. There are other projects like Crossplane, which are basically standardizing infrastructure across Kubernetes in any cloud, whether it's public or private. So basically, there is a lot of pressure from all sides, and the adoption of Kubernetes is going to be inevitable. Moving ahead, let's look at it from a technical angle. So in order to understand why data protection is needed in a Kubernetes environment, it is important to understand the evolution of an application. So if we Think about applications in the client server era when it had just taken off. You had applications running on bare metal servers. When these applications were running on bare metal servers, they were, huge monolithic applications, tightly coupled, tightly integrated, but not very dynamic, and they would work within the confines of an operating system. Sometimes what would happen is that the software or the application vendor would break it up into a middle tier, front end tier, and a back tier, and try to distribute it across multiple servers. But the overall architecture of the application still at a high level was tightly integrated components that couldn't maneuver or move independent of each other. Then came the virtualization technology. What we see in virtualization is that the application architecture did not change, but what you were able to do was put more of these applications on the same physical hardware. So you were able to get better densities, better efficiencies out of your physical infrastructure. But the application architecture or the application DNA did not change. It was still the tightly integrated component fitting within the boundaries of an operating system. Now enter cloud native or Kubernetes based applications or microservices oriented applications. And as the diagram shows, what has happened is now the application has been completely deconstructed into the smaller microservices. All these microservices have their own identity. They have their own nature. They work independent of each other, and they have persistent volume sometimes associated with it, which constitute to the data aspect of it. So now, in order to protect this application, a solution needs to exist that understands these application pieces at any given point in time. What complicates things even more is that these microservices have their own identity and they all have to be collected depending on their scale at a given point in time or what they may be doing something else at any given point in time. So basically, collecting this application footprint becomes a challenge. Now, that we've seen, we need a different strategy or a different way of protecting these cloud native applications. And we know that traditional technologies are not going to be able to protect them successfully. Let's look at what do we need in a solution that can support these requirements of a Kubernetes or a cloud native aspect. And as mentioned before, we are going to go via a user journey talking about the deployment, backup, restore, all the different operations that a user will be carrying out working with such a technology. So at the very top, first requirement is that the application has to be Kubernetes or cloud native. There is no point in running a legacy technology with your Kubernetes environment because you are going to always be lopsided, or that will be the single point of bottlenecks for any kind of scalability aspects needed within your environment. So you want your application or your technology to be Kubernetes native. What this will also provide is a single workflow, a single philosophy for managing all your different applications. You have a Kubernetes based application, data protection solution, managing other Kubernetes applications. So you use the same kubectl commands to manage it, operate it, and work with it. And then similarly, we know that cloud native applications or Kubernetes applications are highly dynamic, highly scalable. So even if your environment grows or scales at any given point in time, your data protection solution can scale with it to protect it successfully. Secondly, Kubernetes has done a pretty great job in making sure that the cluster is multi-tenant. Developers and operational admins can access the same cluster for doing their work. So making your application or the data protection technology Kubernetes native is going to enable scope-based install, whether you want to install it at an entire cluster level or just at a namespace level, and scope usage. You can tune it and tweak it so that you get delegation of services and actions and so on. And what this also means is that when you are building these Kubernetes native technologies or a data protection solution, You need to ensure that you employ all the security best practices, not using cluster admin roles, making sure you use the right service accounts, no root privileges, and also ensure that there is a documented uh, page or a documented list of all the different permissions and policies that the technology may be using. Uh, Building on top of that, we also need to make sure that the technology that is being leveraged uses all the right Kubernetes concepts like custom resource definitions, CSI interface to talk to storage so that you're not bottlenecked working with just a single kind of a storage, leverages secrets, and so on. Now, obviously, we want to use or we want a technology that leverages CSI because CSI is the de facto technology for talking to storage via Kubernetes. Now, this does not mean that you should not invest in any, integrating with any storage platform much deeper beyond that what CSI provides. If there are value differentiators, for working with a particular storage system, that does warrant going beyond the CSI aspect of it. And then finally, we want to make sure that the solution that we employ or we deploy does not use any legacy concepts, because if every time you use a legacy concept like a VM based technology or some kind of an access node, it's going to throw you back and going to cause that single point of bottleneck, which is going to affect your cloud native or your modernization journey. Next, let's talk about what you want to protect from the user's perspective. Now that we've spoken about the deployment aspects, how it should be constructed, what a user needs is he wants to be able to capture all his applications. And when we talk about the application, we're talking about all the images, the metadata, the data, everything that a Kubernetes-based application may comprise of. Now, there are multiple tools available today, management tools like Helm and operators that enable you to package up and manage the life cycle of an application. So you want to make sure that you can use the same constructs for protecting those apps, and not only just protecting, but when you do restore them, they should still maintain that application management tooling consistency. So when you back up a Helm app and you restore it, you want to make sure it's still a Helm app, and same for operators. The next point here is labels. Labels are becoming extremely popular for managing and tagging different aspects or different similarly related services within Kubernetes. So supporting backup by labels is also an important aspect of any data protection solution. Similarly, like applications, you may want to have namespace-based protection as well. The reason for that is there is no standard definition of application within Kubernetes today. You have stateful sets, you have daemon sets, you have deployments. All of those are workloads which could be an application for you. So one of the trends that we have seen is that customers are doing a one-to-one mapping between a workload or an application and a namespace. So having a namespace-based backup will make a lot of sense in that case. However, certain things need to be kept in mind that this will definitely introduce some overhead in terms of operational hygiene, and it might even make your backups a little more fluffy than required or more heavy than required. But definitely, this is good from a service provider use case perspective. You have tenants running in your organization, you have an admin, and the admin can back up the entire namespaces while the tenants can do application-centric backups for their apps. Now that we have gone through the deployment and understand what we want to back up, there is an important aspect of application discovery that is needed within Kubernetes. If we go back to that evolution of application diagram and think about how these microservices are all spread out across a cluster, and there is a challenge in terms of identifying which microservice belongs to which application, there needs to be a better way of identifying what you want to back up. And to make this problem even more complicated, Kubernetes skill sets are lacking today in organizations. There is no standard definition of application, as we had mentioned earlier. Sometimes labels may not be sufficient. What if you miss labeling an item? What if you add more components? Cloud native applications are continuously going to grow. So how is someone going to continuously keep track of all these different labels that are running within a cluster? You want to be able to identify all your applications that you want to protect. You want to be efficient in terms of what you are selecting to backup, and you want multiple views to slice and dice the Kubernetes namespace or the cluster to give you multiple views to select what you may actually be interested in and define it successfully as well. So you may want to have two Helm applications that you want to back up together. You should be able to cherry pick both of those, concatenate it with a label based application, add another operator based application, and call that as your backup unit. And then obviously, we are living in a multi cloud and a hybrid cloud environment. So we want to make sure that all of this is possible across several cloud domains. So whether it is your edge, whether it's your core or your public cloud, you want to make sure that this is all available and you can manage everything from a single source of truth. Now that you have identified your applications, you know what you want to back up, you do want to make sure that you have uh, proper mechanism for hooks, policy management, and security. Hooks, policy management, and security are not new concepts. They've been leveraged for data protection forever. What hooks allow you to do is inject commands to before and after a backup so that you can get your application in a consistent state, or if you want to create additional workflows on top of your data protection workflow. Now, the challenge here is that back in the day when we had virtual machines, we would basically, have some SSH script, get into the VM, inject some QSing, QSing commands, get the data intact, and then do a backup. Now, obviously, if you do the same thing within a Kubernetes environment, that's not going to fly because that poses a big security risk. So you want to make sure that the technology that is being leveraged or that is being selected supports hooks in a secure fashion and is applying the right principles of Kubernetes. Secondly, you do not want to continuously keep doing backups day in and day out or every hour by yourself. You want automated policies in place. You want to make sure that these policies can dictate scheduling, can dictate retention and compliance. Uh, Now, making these policies feature rich and easy to implement and understand is a key aspect because you're going to be dealing with a plethora of applications, a plethora of data. So, making it as simple as possible is going to be key. And then finally, we've spoken about data, how the data is growing, data needs to be protected and secured. We need to ensure that the solution provides encryption technologies. Encrypting your data in flight, encrypting your data at rest, both are very important. As we mentioned, right, artificial intelligence, machine learning is going to be built or thrives on data. So securing that data as a costly asset is going to be very important. Now that we have defined the deployment, identified our applications, know what we want to back up, let's talk about where we are going to store this backup. So what we're seeing all around these days, object-based storage like S3 is becoming extremely popular. There are several reasons for this. One, it is object-based, so it's extremely scalable. Secondly, Amazon AWS basically has done a great job in popularizing S3 by making it super scalable, super highly available, and has become the epitome of standard for object storage in a way. Now, because of the popularity, there are also storage platforms on-prem that are implementing the S3 API so that you can do object storage on-prem or S3-based storage on-prem as well. So you want to make sure that the solution supports S3, obviously Amazon S3 natively or directly, and also has support for other on-prem based S3 storage. Next, what you want to make sure is that NFS-based storage or file-based storage is also provided as an option. There are many organizations that are embarking upon the cloud native or the Kubernetes journey, and they still have a lot of traditional technology and NFS-based storage that is running in their environment. And providing the option of using NFS for the backup repository enables customers to get started quickly. From a lift and shift perspective, it's a great feature to have. It's the ease of use, and also from a scalability perspective, you want to make sure that you provide an option of S3 and NFS to your customers. Next, now that we have figured out that what kind of backup repository that we are going to be storing our data in, let's talk about the schema as to what is the format that you want to store the backup in. So right at top, we want to make sure that the solution that is being selected does not use any proprietary schema on the backups. You want to make sure that your data is free for you to use, even without the vendor in the picture. You may want to create additional workflows. You may want to build in additional analytics. There are use cases like we mentioned, multi-cloud, hybrid cloud, for which you may need to transfer data from one site to another site, or read data at another location from a primary location. There are use cases like edge to core to cloud. There are architectures for, again, artificial intelligence and machine learning types of value use cases that you need the data to be openly accessible. So making sure that your backup schema is an open schema is paramount. Now that we have done all the application discovery, we've applied all our hooks and policies and security principles, and we've stored them in an open format. Next comes the restore step of it. Backup is complete, and now we want to restore the application. Then when we do a restore, we want to make sure that the technology that we leverage or we have selected is intelligent in terms of restore. What do we mean by intelligent restore? One, you want to be able to do selective restores. So as I had mentioned, when you define your backup unit, you may have a Helm app, operator app, label app, all three working together. But for some reason, you may only want to recover or restore your Helm-based application. So selective restore will help you in doing that. Now, what if you have your backup data, but you just want a single table or a single item from the data volume? That is granular restore. You want to make sure that the technology supports both selective and granular restore to give you the edge over managing your infrastructure cleanly. And then finally, the other aspect that we need to be very cognizant of is that Kubernetes is abstracting a lot of different things for you, because of which there is a lot of metadata that is generated. Now, when you take an application from one cluster to another cluster, basically you are backing it up and restoring it, you want to make sure that you have a intelligent way of tweaking and configuring the parameters before you restore your application. Parameters like the storage class to use, the volume snapshot class to use, the security context to leverage, or you may want to make changes to the port that is leveraged by the application. So all those intelligent pieces must be provided as features by the data protection solution. We all know today that we live in a heterogeneous world. There is no one homogeneous solution that fits all different use cases. So ecosystem integration is something that needs to be carefully analyzed. Today, there are multiple tools like Prometheus, Grafana, Fluentd that help in terms of exporting metrics, visualizing those metrics, getting well-formed logs in a single central repository. So these are becoming more and more mainstream with concepts of Kubernetes. So one of the things that you want to ensure is that any technology that you're selecting can easily fit into these ecosystem tools right off the box. You do not want to go through multiple hoops to ensure that this product integrates or not. You want to make sure that that is provided natively by the application itself. And over time, there are going to be other de facto tools that are going to be established. So we want to make sure that whoever is the vendor is leveraging those principles and continues to provide integrations and visualizations natively for the data protection solution. We've we've mentioned, Kubernetes is really a hot market, growing really fast, and as a result, there are multiple new players emerging. So it becomes even more challenging for customers to figure out, hey, which is the right technology that we need to use? Which is the right technology that is using the best practices that is going to help us in our modernization journey. And the answer to that is that there are multiple leaders in the container space, IBM, Red Hat. They all have so many different certification suites that ensure that any application that has been developed or goes through that certification has made sure that they use best practices in terms of security, interoperability, making sure network practices are solid, implementation, it's completely enterprise grade, and it's a resilient architecture. So definitely ensure that there has been a third-party validation of the software, of the technology, so that you do not rat hole yourself in the future somewhere. And then finally, the 10th and the last requirement from our perspective is efficient data handling. Going back to our business problem, there is a lot of data that is being created, right? So you want to make sure that when you back up this data is being stored efficiently. If you just do a data dump into the target repository, it's going to occupy a lot of space. There's going to be a lot of network chatter, and your costs are going to be very high. So what you want to make sure is that there are items like deduplication, change block tracking, only minimal amount of changes, data that are being sent over, so that not only are you saving space from a capacity perspective of storing the data, but also from a network perspective, you're sending lesser amount of data and your backups can complete faster. The other aspect of data protection, what you see in today's world, is that there are a lot of different open source technologies out there. From an enterprise perspective, always make sure that when you're leveraging an open source technology, it's being supported by another enterprise vendor, so that in case there are issues and challenges, you have someone to go talk to and get help from. These open source technologies are a great catalyst, but always make sure that you have some support coming with the open source technology. And then finally, data protection is not new. We've said that a few times. The copy transfer protocols have already been there. Take a look at the history of the ISV, figure out what have they done in the space. Is it a mature technology? Have they done good innovation on that front or not? And that will help you select the right tech. Now that we've completed going through the top 10 requirements of a cloud native or a Kubernetes native solution or data protection solution, let's summarize what we've learned so far. Before getting into the summary of the top 10 points, let's take a look at the use cases that are enabled by this sort of a solution. So point-in-time backup and recovery. We've been speaking about data protection. So, protecting yourself from corruption, from ransomware types of attacks, you should be able to do that. Disaster recovery. In case you have a primary site and a disaster recovery site, you lose the primary site, you should be able to bring up all your applications and your data at the remote or the target cluster. A backup plus restore technically is equal to a clone. So data management use cases also become part of data protection use cases in a way. So things like accelerating CI/CD by cloning your production copies into dev and test, making changes, moving them back into production, become solid use cases that developers can leverage. And we mentioned this a few times now. We live in a hybrid cloud, in a multi-cloud world. So migrating your application, taking your application from one cloud to another cloud, whether it's for cost reasons, scalability reasons, or fees or management reasons, you will have to do that more and more. So these are the kind of use cases that you want to ensure that the data protection solution is able to deliver, because that is going to ensure your organization's success in the future. With that, let's quickly recap all the top 10 reasons that we've gone through so far. So firstly, we need to be Kubernetes and cloud native. We want to make sure that a Kubernetes application is managing other Kubernetes applications for scalability, management, security, all those kind of reasons. You want to make sure that you're able to back up your applications as well as your namespaces, because in the lack of a standard application specification, people are doing a one-to-one mapping between an application and a namespace. You want to make sure that your applications can be discovered. You want to slice them, dice them, create your own backup unit. You want to be able to ensure that you can enable hooks, policies, and can encrypt your data from unauthorized access. Backup repositories, provide customers a choice in terms of object storage, file storage, S3, NFS. Make sure that your backup schema is in an open format and there is no vendor lock-in. Intelligent restores, make sure that you can do selective restore, canonical restores, can do tweaking, massaging of the metadata before it gets stored or gets placed onto a target cluster. Integrations and visualizations. We live in a heterogeneous world, so we want a product that easily fits into all the different tools that we've already been used to. Certifications. Market is new. Certification is a good way to ensure peace of mind on the technology that you're leveraging. And then finally, efficient data handling. Technology or techniques like deduplication, efficient change block tracking, doing incremental backups. Definitely focus on that because data is growing and you need to efficiently handle this data to be successful. So with that, I conclude my presentation. That's me. That's me before the COVID era. And if you want to learn more about what we are doing at Trilio to capture this market and to solve customer problems, feel free to reach out to me. My Twitter handle is right there at Kochuvara. You can also visit Trilio.io and watch a demo of what we've been doing, experience some online labs, and download the product. And to understand more about the company, there are a few handles over there, info at Trilio Data, and the LinkedIn company profile. With that, some additional exciting news, the top 10 requirements for cloud native data protection. We are launching an ebook around this as well, which is going to be a much more detailed version of what I have presented today, adding more color and more light and insights as to why this is important and how to select the right product for your data protection journey within Kubernetes. So with that, log on to www.trilio.io and register for your copy of the ebook today. With that, I'll sign off. Thank you so much. And thank you so much.